You will get time. Okay, we're going live. Welcome to the Big Data Conference in the Machine Learning track, and I will be your host, Priyanka. So let us start a session by introducing you to our speaker, Jameel Nabbo. He's a cybersecurity researcher for over 12 years, and currently he is leading the red team for the biggest consulting firms in the market globally. In today's talk, he will be talking about neural networks and the source code. He will share his research on how it is possible to use ML and neural networks and source code itself to find any security flaws without actually executing or building the source code. I now invite a speaker to present his talk.
Yeah, thank you. So to start sharing the screen. Right, so yeah, thank you for attending this conference. And this talk is going to be mainly about, the way of doing static code analysis and also machine learning and neural network on unsupervised learning on the source code level. So the agenda of this talk is mainly about the professional perspective and also the scientific perspective of building what I call virtual compilers. Well, normally the term compilers exist for normal, let's say, interpreted languages or compiled languages. But the term of virtual compilers is mainly you create sort of compiler, and that doesn't execute the code. So it's mainly lixing and parsing the source code to generate nodes and do the data flow graph type of analysis. We'll also focus on a bit of the algorithm way, what kind of optimized algorithm that I can use, the business problems, also from professional side perspective or consultant side perspective, and then creating the native parsers. So the focus of this talk is really about the offensive security side. So it's a kind of mix between scientific analysis for the source code or implementation of these virtual compilers, and also focusing on the vulnerabilities within the source code. People write source code, developers write source code, and then within that source code, you get vulnerabilities that arises while writing code. So and methodologies and stuff that perhaps can secure the way that you write in your source code. So that require analyzing the source code, of course. But you could also get a bit of different things when analyzing the source code, which is stuff related to the complexity. Say that you got multiple loops, regardless of the language that you're coding with. The reusability, the maintainability. If other developers, leave the project, others come, to understand it. So it requires the code to be written in a certain way. But for this, the analysis is a bit easier than finding vulnerabilities because, let's say, when you write certain blocks of code, it is easy for a machine to break it down into nodes and lex it and pass it. But the problem here, or the biggest problem to solve, which I think is one of the most difficult problem in the computer science, is that you would need to understand the context. And understanding the context sometimes require the human intelligence. So right here, what we're trying to build is a machine brain that is able to analyze certain data flow graphs calls within the source code. Let's say you've got a function, you define this function in a different file. You got extend or interface classes, and then you start to implement these classes. So understanding this is easy, but the context is a bit hard. So which class is authenticated, which class require admin privileges and stuff, and sometimes you load stuff from configuration files, and the configuration files is not included in the project that you want to scan. So all in all, it's all about the offensive side of security, meaning that, let's say, SQL injection vulnerability, Second type of order injection vulnerability, stuff related to communication, microservices, and all of that require building, context around it. So a bit about me. I'm Jameel Nabbo. I'm leading the direct team in the consultant firm. I'm mainly focusing on the offensive side of security. Also, doing a research degree in the computer science, PhD student, as a part timer. And last 4 years, mainly focused on the programming languages design and implementation and the application security side. So built sort of projects within the university, and then we put in some open source here and there for analyzing the source code. So to start with, the more code you write, it's obvious that you would have more bugs. What that means, you got different sprints of the code, you got pipelines, these CI/CD pipelines. The code get bigger and bigger on a daily basis. It's the same as the more you know, the more problem you got. It is the same here when we're writing code. So more bugs. Some bugs could touch upon stuff related to the application behavior or deployment or development, and some bugs related to the security because you got, for example, Q&A and stuff. But on the other hand, some bugs that related, let's say, the application crash, then that touch up on security, like denial of service type of attacks. So now, how do we find bugs normally in the application? You got two type of analysis for any application that could be mobile, web, network, and application, desktop, whatever. That basically applies in any code that is written. So the static type of analysis, you basically analyze the source code without executing it. Means in the pre-compilation stage, no need to compile it. It's just that the code is presented in a textual data. And right here, you've got, the binary type of analysis. If you're dealing with binaries, you do reverse engineering. You do, analyzing the software composition analysis, for example, is CA on the dependencies that is used in the application. But the focus here in the code review, it is like you manually, let's say, a skilled developer or development team lead, he reviews what his team writes in of code. The second type of it is the dynamic analysis, where you basically interact with the application in a form of penetration testing. You're basically fuzzing the user input, you tamper the data, and that could be throughout proxy tools like PopSuite, Fiddler, any proxy tools, basically. Um, so the difference between these two, and the first stage, the code is not deployed. You don't see the code outcome or output. You just mainly, see similar to logs, just source code, text data. And in the dynamic, you got everything is compiled. You can attack it. You can, have multi-factor authentication, so to say, to see the way to bypass it and stuff. So it's a bit known that the dynamic type of testing is the penetration testing that and the term in the market. Right here in the code review, we're trying to replace the human doing a code review, but only focus on the security side, they say. Right. So how do we do code review? You got so many ways to do that. And the shortest, the more expensive becomes. Well, I can basically share it with the security consultant, security folks. But let's say if you got 12 million of code, basically, time is money right here, and that's really an expensive way of doing it. You know, to give it to security consultants to analyze that source code, and at the end, the security consultants, I don't think that would be one person going over 12 million line of code in a limited amount of time, and also taking into consideration the cost that arises and his brain to cope. Because normally, according to some statistics, whatever skill you are in reading the source code, it is normally after reading 500 lines. So I'm just not saying browsing, reading. Reading means reading and understanding. Um, the average human will not be able to proceed in more understanding after reading 500 lines of code. That requires, a bit of intensivity, focus. Um, so yeah, after 500 lines of code, you would need to take at least 5 to 10 minute breaks, and then come back to analyze the next chart of the source code. You got another way of doing it, which is also buying expensive tools, the automated tools. By the time that we're doing the stocks 2021, and still the automated tools adding at the top of, they are expensive, but they also proceed a lot of false positive. They of course useful tools to do the code review, but they are also expensive. So the tools that are premium in the market, which you got two, three, they're standing out um, to do this type of analysis. And mainly they charge based on sometimes line numbers. They require highly specifications of the server that you're running this tool at. Well, speaking about millions or billions line of code, then you would definitely not gonna work with 4 GB of RAM, for example, in these tools. And also they don't really understand context, as I say. That's something related to the human brain. So right here, the neural network, we're trying to build this context in this research. And they also charge based on developers, the amount of project that you can scan, and sometimes on a one subscription for a yearly subscription that could go over 250,000. You got another cheap way of doing it. We're using grep sort of regular expressions to catch these low hanging fruit. Let's say you write a regular expression for yourself to analyze the outdated library. You define them, but that also comes with a lot of time consuming. Or you simply take the block of code that you don't understand, you Google it, you go into Stack Overflow. But then this becomes another problem, because not all the answers for the code in Stack Overflow are secure. So here a bit of challenging stuff when you face application security. If you're gonna be analyzing, let's say these are just the quick figures on the internet about statistics of how many lines of code, say LO0 stands here for the lines of code, and the Chrome and the Chromium engine, the Mac operating system and stuff. So if we speak about 50 million line of code in the Windows Server 2003, you need definitely a tool to review 50 million line of code, because if the humans start on this, let's say one guy or two guys start on this, probably they're going to finish after 1 year. So you would need tools. The tools at least would give you the starting point of where to look. And that could be throughout obvious score, SDR copy, for example, if you analyze in C, so you focus on these pull, and then you start analyzing from that point to see if it interacts with the user input. Um, the issue, however, with the premium tools, they are of course very expensive. You have no idea where the code is being uploaded to. Um, that could be, for example, the cloud. You don't have an understanding how the cloud is built, and normally for some, sensitive areas like banks and government client, they try to get away, or research institutions, healthcare, drugs labs, they try to get away from stuff exposed to the internet or a third party where they don't trust. I've seen over my experience, with going to throughout the consulting experience, going to customers. Some customers say we don't want the code leave the building. We cannot, give you the code in a USB stick, or share it with you, or give you access to the version control. You can analyze this on our laptops and our PCs, and there's no internet access. So you get sometimes, this type of client depends on the sensitivity of the area that you're working with or you're dealing with. Um, and when you even go to purchase the premium tools, right here, most of the time that you would need to install the license, and the computer that the customer could give you, it takes a bit of time to install the license and also to make sure that it's working, installation hassles, and these stuff other than the cloud. And of course, you get always false positives. This is that the focus also here is to solve this problem in a creative way or scientific way. Um, if you can also use the open source and free tools, just to give you a bit of context about the problem here. But with these tools, as I say, they only catch the low hanging fruit. It's not supported. The developers who created, they create it in their spare time, for example. It's not meant to be a research. And there are a couple of tools in the market, but it's a free, of course. But at the end, it's either unmaintained or you need to write rules. You need to understand how the tool got built, the complexity, and let's say if you get only 10% out of reviewing 50 million line of code, you still have a problem. So that's a way. Sometimes it's better to move the premium tools. Depends on the context. Another thing right here in the open source tools, they don't support all the common languages, and that sometimes you may use a tool that is built on the version 2.7, for example, of Python, while you're trying to review Python version 3. So that also something becomes as a problem. So how do we analyze the source code? All of these ways, it's either using regular expressions, that of course for catching low hanging fruit, or you can use parsers. The parsers require specific skill set for understanding a bit of computer science theories and also how they got built, how to extend them, how to get the output out of them, of course. And then it's like I'm saying, write yourself another copy of GCC compiler. That in a similar case. Now you get also the control flow graphs or the data flow graph analysis, which basically parses. You build parsers and lexers, and at the top of the parsers or lexers, based on the output they give you, you start doing some certain rules, function calls, tracing the execution flow in uncompiled way, or you go with the route of virtual compilers, which a new term, that we state in our research. So with this talk, we focus on the virtual compilers and what they stand for. Now, to give you a quick example about the limitations that you would face when using regular expressions on the source code. Now, think about the source code. You've got, let's say, you've got many machine learning tools, AI tools to analyze certain data structure. Now, this data structure could be, let's say CSV file, could be table and database or entire database, or it could be also logs. You got them from different sources, but all of this is simple when you compare this to the source code, because the source code is like the human spoken language, but for the machine. And it's not only about reading instructions from left to right or reading rows. You get data trimmed or CSV files, data already structures and stuff. Right here, you have no idea about what the source code could be, what could contain, and how to link things together. So it's yes, unsupervised learning, but it's I think one of the most complex things in the open unsupervised learning, because it's a context free. Reading the source code is a context free language. Now, right here, a quick example in PHP. Let's say right here you echo, you brand. The dollar underscore get stands for getting the user input throughout a parameter called search. So right here you get the user input throughout a search. So when you say, for example, echo dollar underscore search, so what happens right here is that you gather the user input and you simply print it. So let's say you got a search bar. This is the way that you print it from the back end. You get the search text keyword, and then you print it. Now, right here, you've got a huge vulnerability, and it's called cross-site scripting XSS. It's mainly reflecting the user input to the output, so it means he can, interact and change the document object model, the web page, the DOM. So this vulnerability, in order to catch it with the regular expressions, is quite easy. You simply specify this type of search in your regex. Um, so you basically say if a string start with an echo keyword, or it has a print, or it has a print. These are some functions to print back to the user. Then you look after that, and then you say if it got followed with another string that starts of one of these keywords, which is $get post or whatever, then classify as a vulnerability. So if we dig into it more, look into the first section here. Um, just look for any of these keywords, and then in the second section right here, look to the rest of the keywords. So you see right here, the limitation comes in analyzing keyword by keyword, and not understanding any context. So just moving from left to right while reading a file. Now, what you're gonna catch right here, you're gonna catch in this regular expression the echo, and then after this, parenthesis and dollar sign, you're gonna catch the get, and you're gonna also catch this open bracket here. You're not gonna catch the rest, but if you face this, then that means, hey, this is could be, a user reflected input, and then it's a vulnerability. But if we're gonna make it a bit harder, you define, let's say you got this user input, but you assigned it to a variable, and right here we call it trim, and then you echo the trim. So whenever you store in, it goes to trim, and then you echo that. If you write a regular expression to this one, our regular expression which we wrote will not be able to find it. And if you're gonna say, hey, if you got a variable that start with a trim and stuff, that wrong, because you have no idea what the variable be, or the variable name could be. And also add on top of that the cultural writing of the naming conventions of the variables and functions. So let's say a programmer from Japan, he could write in his code in English, but in the Japanese meeting. So you cannot really cover what the variable's name could be. You may say, okay, I got a data set of potential variable names and stuff, but that an endless way of doing it. And as I say right here, our regular expression, that the simple one we wrote will not be able to detect, this simple assignment. Now, if we see the limitation in more deep eye, the one that we wrote, he gonna look for $_get, and then the open and bracket here, and then the echo keyword. But since these are broken into two multiple lines, it won't match. Even though that, let's say, if you're using the regular tab, the modern one of the regular expressions, where they support back tracing, you would also add a lot of rules, to detect these kind of things. But at the end, it will come up with a lot of false positives. So whenever there is echo, whenever there is $get, it doesn't mean it's a vulnerability. It doesn't mean at all it's a vulnerability. Now, to take it a step further, which makes it impossible for regex to analyze. You see that we take it into multiple level for this example. We got the trim variable. He get the search value. You got echo of a function. So echo right here calls the cleat function, and then it passes the parameter that we've got. And if we look to this function right here, it's apply another function in the language definition in the PHP itself, where it clears all the HTML characters. So whatever get printed here, it would be escape. So that means whenever the attacker or the user injects in the search parameter of HTML statement, it will get trimmed. So it will be encoded, and it won't be a vulnerability. So this is definitely not a vulnerability at all. So how do we write a regular expression for this one? It's impossible because right here, we need to figure out the function calls. We need to trace the function calls, and then we need to see, in which file. That is even right here. I'm speaking in a single file, but that function could be extended from a class. It's really difficult to figure out which class inheriting what, implementing which interface, in which file, with only using regular expressions. Well, it's kind of impossible. I tried it. It's impossible. So um, regular expression right here is not designed to pass programming languages. The programming languages are context free, which means you cannot really or potentially catch or expect what would be the next line. That's really difficult. And that's even difficult on the human brain. Let's say if I give you certain block of code and tell you complete it, so you have no idea what the next would be. If I give you authentication, so what after the authentication? So let's say a login function, and then I tell you, okay, fill in the blanks. You have no idea what the next line would be. Same as the machine. So in the regular expressions, it's even limited for analyzing line by lines. Unfortunately, in the open source market, it's heavily used, regular expressions, and most of it for catching, passwords or stuff, but not catching the vulnerability where it requires multi-stage type of exploitation. Um, so the question becomes here, how do I do code review at low cost? So you can basically list the patterns to search for, the outdated libraries that you would like to enumerate within the code base, and you can use the regular expressions or simple file reading. Let's say in Python script or Bash script, simple file reading, and then you match file names, file versions with certain rules that you've got. And as an example here, that could be for the hard-coded keys, because some keys like AWS keys, Slack keys, Twitter keys, Facebook keys, whatever, got certain patterns. So like the RSA key, it start with BGP and these not. It got at the end certain patterns. So you're gonna get false positives, but at the end, this you need a solution um, for doing a code review on large code bases. So yeah, that could be for catching on hard coded keys. You see, we cannot really rightly catch deep vulnerabilities. And what is the right way then of doing a code review? Well, simply there is no right way of doing it. um, it's basically every single consultant does it in his own way. There is no standards or definition how to review the code line by line and stuff. So it just sort of checklist in the, let's say, OWASP standard or NIST 100. It's sort of checklist that you it's like compliance stuff. It's not really deep stuff what you need to look for in terms of functions, and calls and classes, because each source code is different, simply different. That could be a content management system. It could be customized software that you're building. So there won't be always a context of how this should be or how that should be. It's just certain checklist. Okay, make sure that you prevent hard coding keys. Make sure that you make the user password 8 characters or more and stuff. So it's just simple as checklist, but it cannot be applied to a customized application, content management system, or basically any application, just to tell you exactly what you need to do, because your application have to be studied first, and then coming up with the checklist on it. So that's why there's no right way of doing it. But I've got some methodologies here for you based on my previous and scientific experience of doing, compilers and stuff. If you're reviewing it, let's say by your own, you've got C sharp code or whatever, you first need to understand the language. Even though that you are a programmer, let's say in Python, but you don't have .NET experience or C sharp experience, it becomes really difficult because it's not only about syntax of the language, it's about how to use the language and how to write, certain stuff, internal scores, libraries, um, you know, these kind of things. So understanding the application context is the most important thing here. So what does this application do really in reality? What is the purpose of it? How things are structured? What is the entry point of it? How it's a start? Is it API? Is it mobile? What is the start of a class? All of these, and of course, then in terms of security, you're going to focus on handling the user input. So, what are the areas, of the user input? What are the places the user can interact with the application? So, to parse the source code, there are a bit of stages, and there are multiple ways, of course, but this is the let's say sort of standards way of doing it. So first, let's say you've got a project, you got the code base. You need to filter this code base from the noise, and the noise that I mean, you are not interested, for example, in images or CSS files. You're only interested in, let's say, a code that can be executed on the machine from backend level, or something that you can define a logic in it and process input. So CSS is definitely doesn't touch upon security, cascading style sheet for building HTML pages, images, videos. These files should be excluded. Now, the second stage of this process would be is to detect the language and the framework. So by the language, it's easy. Let's say you write a web application. That web application uses PHP, but also the modern applications separate the front end logic from the back end logic. So right here, let's say you got React, you got TypeScript, you got Node.js, and then you got Python in the back end. You got Terraform, for example, for infrastructure as code. You got DLL libraries and stuff. So right here, you're not gonna end up with only detecting one language on any, let's say, application. It has to be, of course. I'm not speaking about scripts, just simple kung fu scripts to run. A web application, let's say, it's gonna be broken down by multiple languages. So detecting what languages you're dealing with, and also what type of framework. So let's say you've got in the PHP, for example, you got Laravel, you got CodeIgniter, you got YEE. So, what is the framework that you're dealing with? Because certain syntax could be different, and when you're parsing that source code, understanding this framework really makes sense, because you would need to know what are the function calls, how the things get traced, and how the execution flow continues. After detecting that, then you load the parsers and the lexers. So, for example, I detected, hey, this is a PHP. Then I should not load, for example, the Python lexer. Otherwise, your application gonna crash, or your parsing techniques gonna crash, because you need to create the parsing and the lexer based on the language and the framework as well. So it's right here in this stage. There is a bit of internal decision making. It is not that complicated to detect what the source code is, but right here, keep in mind, I'm not speaking about single file. I'm speaking about entire project. So entire project, then you need to define every file in the project. Not only work on the extension, not only on the memory type, but also on the source file code content. So you need right here, it could be with the data mining techniques and stuff. And after this stage, now it becomes the computer science theories, is to build something called AST, or the abstract syntax trees. Think about the abstract syntax tree when you build a compiler. It's a representation of the source code in a tree, in a JSON tree, to make it easier. And then after you build this tree, you got a base where you can resolve classes and namespaces. And after that, you can start, for example, analyzing back and forth in each tree to do queries to catch the malicious calls to functions, to vulnerable functions like str, copy, and say, and then make sure when catching certain functions or patterns, you've got no data synthesization on the user input. Otherwise, you're going to be reporting false positive. Now, the next stage would be right here is to trace the user input and the symbols. Um, so let's say that you got a login screen, you got a function where it does the login, you got the two parameters, the user, the password, or maybe remember me, whatever. So right here, you start from that point to trace that input parameters. Are they synthesized? And detecting the framework right here is also linked to this case, because for example in the .NET Core, even though that if you don't trace the input, XSS attacks is not possible unless you allow it to the user to type plain text cipher of HTML, code. So you see that in certain stages you would need to go back to the framework that you detected to load the rules for it. Now, right here in this stage where it becomes the neural networks and the analysis, because right here you built all of the stuff, you took the abstract syntax tree, you licked the input, you passed it, you start tracing. Now, when you start tracing, when I say that you start from analyzing the user input or the symbols, from this point, you basically start to draw your node. You start to inspect these parameters, where they are going, into which classes, to what return statement, is there any if statement, does a certain logic and stuff. So here's the most difficult problem to solve. And I think in general, I pass logs, I pass lot of large data set and stuff, but the source code is the most difficult one in my opinion in the computer science. So to talk about the abstract syntax tree, to break it down here, so we've got this if statement, and you see that in if statement you are saying if x is bigger than y, then right here you see that there is an equal sign. The max is then x, and then the max is y. So all of these instructions, all of these symbols, get into the abstract syntax tree when you convert it to abstract syntax tree. And how to convert it to abstract syntax tree, I'm going to speak in this about this in a minute. But this is basically the logic. So every single symbol, every single variable got broken down into a node. You see, this is a node. It's not a tree. It's a node. So a node could contain multiple nodes, and the multiple nodes could go endless in nodes. And that a simple thing. If you got a complicated loop and nested loops, then you can imagine how the AST would be a bit difficult. Now, the abstract syntax tree, we got right here the AST, so that the AST is built, and we started on the control flow graph. So you see that there is an entry point of a declaration. So this is how it's started. It goes into the declaration point, and then it digs into the variables, and the other stuff in order to come with the output. So how to do the abstract syntax tree? There's already a research that is written by me, and also by other professors like David Bisley, who created Ply. There's Antler, and there's a parser where I extended also Ply parser for parsing PHP in Python. You can find it on the GitHub. So the best way to start traversing throughout these nodes, throughout the BFS, the first search type of algorithm of analyzing the points, the search node, the subnode, and moving to the neighbor nodes. So this way, in the heading, stage of the neural network where you build these layers, and then based on that you can start the learning curve. Now, in more specific way, right here, I'm showing how that could be. So the algorithm start traversing for the graphs from a certain node. So if the node got children's, or other nodes, so he gonna basically pick up the nearest one and then go to the others, like k-means algorithm. But this one is more specific to the, let's say, to analyzing certain trees of control flow graph. Now, the building static code analyzer, I'm right here. I'm not targeting a language, but that could be applied to multiple languages, regardless of the language. Right here, it's already context free. So we're trying to analyze the source code as a textual data over here. To show you a quick of demo, um, taking into consideration the timing here. So let me share my entire screen. So on the left side that you see, this is, for example, a virtual compiler for PHP. Of course, we've got multiple virtual compilers, but this one for PHP, and the way to invoke it is I can say, for example, um, PHP SAS. So I'm gonna pick up the open redirect vulnerability. So I'm gonna scan right here the examples directory on the right side. So when I scan it, and then we go to look on the examples directory on the open redirect. So it says, hey, you've got in the open redirect class a line number 14 and open redirect vulnerability. So open redirect class in line number 14. So right here, I'm displaying the complexity of what virtual compilers and using neural network and the learning curve could be, and you see how fast it is when we build and analyze the language in a native way. So we see right here the line number 14 got reported as a vulnerability, and if we look closely to line number 14, it got a parameter called URL, RURL, and RURL is basically calling a function called function 3. And if we look to this function right here, it's not exist in this file. But if you look at line number 5, you see that we extending redirect parent class, and redirect parent class is loaded. So you see the virtual compiler here is able, without executing the code, to analyze the code. So parent function 3 is defined then in redirect parent class. So redirect parent class have the parent function 3, as we can see here in line number 15. But then another complexity right here, this function calls in recursion manner another function, which is right here, function parent 1. And the function parent 1 is then defined in the same class. And right here you see there is a variable who get the parameter m and o in a get way without any synthesization, and then it's return it. When it return it, it goes to the function number 3, and then it goes to function URL redirect 1. So you see that trace type of thing is the same way that I was presenting here about nodes and stuff, but on a more complex level, on a recursive call, um, in different files. So if I, for example, right here, go and say, hey, this is ABC, is not coming from the user input, is basic, sorry, it's not coming yet from the user input, it's coming from the code, then line number 14 should disappear right here. So if I simply just clear it, or scan it again, you see that line number 14 is not reported anymore, and it moves to line number 19, where it's another function. So that is the powerful way of analyzing virtual compilers. Um, I think we basically
We have a few questions for the speaker, and I'll read them for you. What would you advise for Python code analyzing?
um, Python is definitely not the best language to analyze the source code because it's very slow. It's interpreted language. It's written in C and basically C Python. So you basically, it's not the best way of analyzing the source code. And mainly, if you got million line of code or more than that, that would really could crash it, or you could wait days and weeks to see the output. So it's not the best way of analyzing the source code in Python. Mainly, it's in Java or in C Sharp. .NET Core is the best in terms of benchmarks.
All right. We are running out of time. I'm sorry we cannot take further questions, but you can reach the speaker, his profile, to get your answers. And lastly, the note of thanks. Thank you, Jameel, for such an informative session, and thank you, audience, for your patience and interest. Another news before ending is that the most active attendees who rate the sessions and leave comments will be awarded with the ebooks of their choice by a Knowledge Partner Pack, and the organization will contact the most active speaker after the conference. Thank you for
Thank you.